Hey guys, Professor Doney here again. Another throwdown problem in our study of vertical motion. Alright, I've written most of the problem out here and got our equations all ready to go just to save some time in the video so I'm not running up into 5 minutes and have to jump out quick. So, doing a vertical motion problem, example number 2, it's a throwdown problem. That means the initial velocity is not 0. So we're going to have an object that is thrown down and 3 seconds later it hits the ground. It is traveling at 40 meters per second when it does hit the ground, and what we're asked to do is find out how fast it was thrown initially. I'm going to find my cursor here. Find out how fast was thrown initially and the height from which it was thrown before it hit the ground. So if we pull out the information we already know here, it's going to be time is 3 seconds, final velocity is 40 meters per second. We still know that gravity is 9.8 because it doesn't say anything about being somewhere else other than the Earth, and it is downwards. What we don't know is initial velocity, and we don't know the height. So that's what we're asked to find here. Okay, so what we're going to do is go ahead and solve this problem. It's a little different, but again, the key here is that we are going to pick positive going down. Why do we do that, or why do I do that, prefer to do that? Well, all the motion of the object is going down. It's starting up top, it's being thrown down, it hits the ground. All the motion goes that way. What that allows us to do is to make gravity, which is also that direction, a positive number. In all these equations, g will always be a positive 9.8. Now, what sometimes happens if you make a mistake and don't keep that as positive, you switch the sign by mistake, is a lot of times you'll find out that when you solve for your time ends up being negative. That kind of implies that we went back in time, and well, we can't do that, and we don't know how to do that, so we should use that as an alert that we probably made a sign mistake there. So, alright, I'm going to go through again, underline everything I know. That's time I know. I also know gravity. I know that too. I know half. What else do I know? I know final velocity is v. I don't know initial. I know gravity there. I don't know initial and distance, initial and distance. So if I look at these equations again, this one has one unknown, this has 2, which is delta y and initial velocity, and this one also has 2. So the equation I have to start with is that initial, that first equation. So v equals VO plus GT. I'm picking again positive down. I'll just put that there to remind me. Final velocity is 40. Initial we don't know. Gravity is 9.8. I make it positive because it is downwards. And the time we're told is 3 seconds. Now if you go through that math, you have 3 times 9.8. You subtract that from both sides. So 40 minus whatever that quantity is. You go through, you're going to get 10.6 meters per second squared. Alright? I did that ahead of time here on my calculator just so I could see it. Now that I have that information, I can go back and say, alright, I know initial velocity now. I know initial velocity. I can solve for distance. So why don't we go to that third equation, only because it's already solved for distance. And we're going to see that delta y is initial velocity, which is 10.6, still down, so positive, times 3, which is a time, half, 9.8, 3 squared. Now I'm going to do some ballpark math here. That's 3, it's 30, about 31.8, I think, plus that's 9, half that is about 5, that's about 44-ish, I don't know, 5 times, 44-ish. Somewhere around 75 meters. I'll put a little squiggly there. I know I'm not trying to be exact here, I just want to show you how we set it up. The math you can do on your own. But there's a second problem on throwing objects down. Now again, you can go through and just underline what you know or circle what you don't know to help you choose which equation. But there's another way to look at it, and using positive as downwards. From here we're going to move towards, well, we throw things down. Let's throw things up and see how we applied those. Alright, we'll see you next video.